This is an introduction to alkyl halides. Alkyl halides are compounds that contain halides attached to sp3 hybridized carbons. We can classify them as methyl halides or primary, secondary, tertiary halides, and this is going to depend on what carbons they are attached to. If it's attached to a methyl group, it's a methyl halide. If the halide is attached to a primary carbon, then it's a primary halide. If it's attached to a secondary carbon, it's a secondary halide. And if it's attached to a tertiary carbon, it's a tertiary halide. If the halide is adjacent to an alkene or an aromatic group, we can classify them as allylic halides or benzylic halides, respectively. The IUPAC nomenclature of alkyl halides follows the same rules as before. Halogens are indicated with a halo prefix in front of the name. And just remember that now we've got the first group that's got higher priority than alkanes. So we've come across halogens, and these have higher priority than alkanes. So if you have two carbon chains, for instance, to choose from, you will choose the one with the halogen as opposed to one without. Now let's try the first example. We need to find the longest continuous carbon chain and give the lowest possible number to the first substituent. So in that case, we're going to start numbering it from here, 1, 2, 3, 4, and 5. We have 3 substituents. We have an iodo at the 1 position, chloro at the 3 position, and a methyl at the 4 position. Putting it all together, remember to alphabetize. It would be 3 chloro, 1 iodo, 4 methyl, and it's a 5 carbon chain, so the parent name is pentane. Now let's try the second example. The longest carbon chain is 8 carbons long. We're going to give the lowest possible number to the first substituent, so that means we'll start numbering from here. So that is 1, 2, 3, 4, 5, 6, 7, and 8. We have a 2 chloro, 4 bromo, and a 6 methyl substituent. Putting it all together, again remember to alphabetize. We have a 4 bromo, 2 chloro, 6 methyl, and in this case we have 8 carbons, so the parent name is octane. Now let's try this last example. Here we have a cyclobutane. We also have to think about stereochemistry. We're provided stereochemistry at these 2 stereocenters, so we need to figure out if it's R or S. In this case, this stereocenter here, we have a hydrogen that's going at the back. That's the lowest priority. The methyl group would be the 3rd priority. This would be the 1st priority, 2nd priority. So we're going clockwise, so this is an R configuration. At this position, we have a hydrogen coming in the front. Chlorine would be the highest priority, followed by this chain here, and finally this carbon, and that is also an R configuration. Now let's look at the substituents. We have a methyl and we have a chloro. We're going to give priority to the chlorine, so this is going to be 1 and this is going to be carbon 2. And so if we put it all together, we're going to start with the stereochemistry. So we have 1R, 2R, hyphen, and then we're going to alphabetize, so 1 chloro, 2 methyl, and the parent name is cyclobutane. There are some common names associated with alkyl halides. Methylene chloride is CH2Cl2. Its IUPAC name is dichloromethane, but oftentimes people will refer to it as methylene chloride. Then we have chloroform, And likewise, we also have bromoform and iodoform, and these three compounds are known as the haloforms. You can also have alkyl halides that are named by the alkyl group, and instead of using the IUPAC name of this alkyl group, sometimes you'll see people refer to it as allyl fluoride, or benzyl iodide, or isopropyl bromide. These are just examples of how people use common names and combine it with a halide. If we analyze the carbon-halide bond, we know that the halide is more electronegative, so the bond polarity has the electrons more towards the X group, which is the halogen, and that gives a partial positive charge on this carbon. Halogens are also very good leaving groups, so they can undergo two different types of reactions. One is a nucleophilic substitution, and that's where the nucleophile is going to attack the alkyl group and kick out the halide leaving group, and you end up with overall substitution of the X group with the nucleophile. In elimination, you can use a base, and the base is going to do a beta deprotonation to eliminate the halide leaving group, and you can end up with a new pi bond, and so you can form alkenes and alkynes this way.